All right, guys, in this video, we're going to be looking at finding the unknown angle measures using a transversal and two parallel lines, okay? Now, we know that a transversal can hit two, or when a line hits two or more parallel lines, we call that a transversal. So again, this symbolism right here, these two black arrows will indicate that, or we are to assume anyway, that the lines are parallel. Now, when we know that the lines are parallel, that's going to tell us certain things that we need to know about the relationship of these angles, okay? So if we take a look here, it says in example number 1 that the measure of angle 2, this angle right here, we need to know what that angle measurement will be if we know that the measurement of angle 7 is going to be 125 degrees, okay? So we're going to backtrack just a little bit, and I'm going to show you another graphic that's going to lead us to that information. All right, so again, the definition for your transversal is going to be a line that intersects two lines in the same plane at two different points. Transversal T, which is this line here, okay, and lines A and B form 8 angles. Now we know that the exterior, and again, when you think about exterior, interior, think about your house. Interior, where your furniture is. Exterior, where the grass and your yard is, okay? So outside of the two parallel lines would be the exterior. This part and this part. The interior would be inside of these two parallel lines. And again, 8 angles are formed. Let's look at corresponding angles that lie on the same side of the transversal. Are in this case 1 and 5. Those are not the only two corresponding angles. So as you notice, this angle 1 sits on the top of this parallel line. 5 sits on the top of this parallel line. They're in the same position, two different areas of the transversal, but same position. These could also be corresponding angles, 2 and 6, 4 and 8, okay? But we're going to call those something slightly different. So alternate interior angles are non-adjacent angles. Again, they do not share a side. They lie on opposite sides of the transversal. In this case, they're giving us the example of 3 and 6. These are the same measurements, 3 and 6. They are on opposite sides of the transversal. However, they are on the interior of the two parallel lines. So they are inside. Alternate areas. When you think alternate, think opposite, okay? Alternate exterior, same concept, where they lie on opposite sides of the transversal, except in this case, they're on the outside of the two parallel lines. Again, alternate exterior, we have 1 and we have 8. So this is on one side of the transversal, this is on the other side of the transversal, and again, they are outside of the two parallel lines. Again, exterior. Same side, interior. So same side, interior. They're giving us 3 and 5. So within these two lines, the interior, we have 2 angles that are on the same side and on the interior of the parallel lines. Now the deal with these is that these angles will equal to be 180 degrees. So the measurement of this one and the measurement of this one will equal 180. These situations are where they are the exact same measurement, and this one just talks about the positioning of those two angles, okay? So we're going to switch back over. So if we switch back to our initial graphic, we want to prove, using what I just showed you guys, that again, these two angles will also be 125 degrees. So remember, angle 2, angle 7. We are going to call these alternate exteriors. So this one is on one side, this one's on the other side. So if you notice, they look to be the same. So the positioning, if the positioning is something that you're having a hard time with, just like I did in another video, we're going to switch this around. So we were looking at 2 and 7. So if you notice, this one also now looks obtuse. Now I know it's upside down, but in some cases you have to do that just to orient yourself. This is also obtuse. That is also obtuse. If that is not something that you're able to see, simply flip it around, and that's what I'm going to do, flip it back, okay? And you'll have the ability to do that if you have a paper, okay? So let's look at B. Find the measurement of VWZ. So remember, when you're naming an angle, this middle one is going to be a vertex, okay? So let's see, VWZ. So we're looking at this angle. W, again, was the vertex. So what is 3x? So if I know, based on what I know about same side interior angles, I know that these two together inside of the parallel lines, again, we have our parallel line symbols. Inside of these parallel lines, we have 6x plus 3x. That together is going to equal 180 degrees. So if I combine those two like terms, 9x equaling 180, x will equal to 20. I'll then simplify 6 times 20, 120. We know that this looks to be an obtuse angle, so let's flip it as I have been. We'll do that one more time. One more time. Okay. So if we notice here, if you look at it in this orientation, you can see that that one is clearly obtuse. This one is clearly acute. Okay, so when we come up with 6 times x, we know that that's going to be 120 degrees. So we know that an obtuse angle is 120 degrees. We know that an acute angle is less than 90 degrees. Let's test this theory out. So 3 times 20 is going to give me 60. Is that less than 90? Absolutely. Okay, so together they will be 180 degrees. Now let's go on to some practice problems. So using these two parallel lines and the transversal, okay, I am going to try to figure out what I know. Also, I'm going to use some information from 6th and 7th grade curriculum where I know that vertical angles are going to be super important. Vertical angle, the prefix of vertical, V-E-R-T, vert, symbolizing that they share a vertex, okay, share a vertex. Vertical angles will have the exact same angle measurement. And so on my paper, what I'm doing right now, and when you have a situation that is similar to this, what I suggest that you do is that you recreate or label, I should say, any drawing that is given to you so you know exactly what you're looking at. I have always been an advocate of labeling everything, in that if you label everything, you don't have to keep going back and trying to figure out what's what. You don't get yourself confused. So at this moment, what I'm doing off camera is I am labeling or making a recreation of the drawing that we see here on the page. Okay, so I am now up to H. Okay, so I think that I have everything labeled and we are ready to go. Now, just using just these two angle measurements that we have, we're going to be able to fill out this entire chart. Okay, so flipping over to my drawings page. All right, so we have to remind ourselves, do we have a transversal? A transversal will hit two parallel lines. We know, okay, that is the case. These two black solid arrows that I have, those symbolize that it is a parallel line, okay? But again, you probably will see it like that. But just for the sake of being clear, I have filled those in. Do we have parallel lines? Yes, we've confirmed that. We have a transversal hitting two lines at two different points, in this case at point D and point E. All right, so let's use what we know. I'm going to try to hone in on this a little bit, make this a little bit clearer. Hang on just a second. All right, okay. So now, vertical angles. I know that we have alternate interior, alternate exterior, okay? We have same side, I'm just abbreviating these, interior, and I have corresponding angles, okay? So let's go ahead and try to identify a couple of these things, okay? So we have corresponding angles. I'm going to say that angle CDA here, an angle DEB. Now, I could have said CEB just as easily, but I just chose D. But for the sake of what we're doing, we'll just say CDA. We'll say that that is angle and angle CEB. Remember, this is whatever you like, corresponding. Alternate interior, alternate interior. So I'm going to say same side, excuse me, different sides of the transversal, okay? But within these two parallel lines, I'm going to say that GDE. And so we have GDE, and we have DEB, alternate interior, within, okay? So let's talk about some alternate exterior. I'll say angle CDG, that's CDG. This is the exterior. This is also the exterior. Alternate sides, we'll say angle. I think that I've left off one of my points. Okay, so let's switch back over. I did, in fact, leave off one of my points. I left off F. Okay, switching back. Sorry about that. Mistakes happen. Teachers make mistakes too. Okay, so I'm going to call this angle BEF. Same side interior, I'm going to say that these two, so angle GDE and angle HED are same side interior. Okay, so using what I know, you guys should have something in your notebooks as well with your notes. Okay, so let's go ahead and try to figure out what was assigned to us. We know that we needed to figure out the measurement of angle GDE and the measurement of angle BEF, measurement of angle CDG. Okay, so let's switch back. Okay, so what I've done at this point is I have filled out my drawing with what I know. I know that, again, if I had 6x degrees, knowing what I know about supplementary angles, I know that these two angles right here are going to be equal to 180 degrees. So if I were to solve 6x plus 4x, and again, off camera, what I did is I went ahead and I solved for 6x plus 4x, giving me 10x is equal to 180. Solve for x, giving me 18 degrees. What I know, based upon what I identified earlier, that these two angles share a vertex, so therefore they are both 6x degrees. I know that alternate exterior angles tells me that if this angle, I'm sorry, the original one that we had, 6x degrees, that if this one is 6x degrees, this one's also 6x degrees. Alternate exterior here, 4x degrees, again, is going to equal 4x degrees there. Same side interior, I solved again for 18 degrees. I'm then going to plug in for angle GDE. If 4x degrees, I will multiply 4 times 18, giving me 72 degrees. Angle BEF, again, 4x plus 6x is going to be 180 degrees. Using what I know about supplementary angles, if 4x degrees is 72 degrees, 180 minus 72 is going to give me 108. I know that CDG, also being 6x degrees, is also going to be 108. Now, guys, as always, come to a tutorial, rewind this video, come to class ready to ask me anything that you want to know. And as always, I will see you tomorrow.